if the object I'm researching is really an exoplanet or not. Okay then, let's see. How to classify exoplanets.
Did you know that identifying whether a signal is a real exoplanet or a false positive can take months or even years for scientists? Telescopes like Kepler, TESS, and K2 collect tens of thousands of signals every year, but over 90% are just noise or caused by stellar variability. Each signal must be manually classified, a time-intensive and repetitive process.
Celest AI detects exoplanets by combining data from NASA's Kepler, TESS, and K2 missions. From just seven basic parameters like orbital period, transit depth, and stellar temperature, it engineers over 25 derived features. Things like physical ratios, habitability indicators, and signal strength that help the model understand the data better.
Systems cleans and pre-processes the data, handling missing values and outliers, then runs advanced machine learning models, mainly CatBoost and XGBoost, to classify objects as a confirmed planets, candidates, or false positives. Users can interact with Celest AI through a web dashboard or API, getting a real-time predictions, visualizations, and explanations of which features influences each decision.
In short, Celeste AI turns raw multi-mission exoplanet data into accurate, interpretable predictions, all in an interactive, research-ready platform.
Once we enter the exoplanet's physical parameters like orbital period, transit duration, transit depth, planet radius, stellar temperature, and radius, Celeste AI processes the data instantly. Behind the scenes, it applies all its feature engineering and processing, then run the optimized machine learning models to classify the object. Not only can you classify individual exoplanets, but Celeste AI also lets you upload your own dataset and retrain the model. Once your data is loaded, the system automatically applies the same pre-processing and feature engineering steps, trains the optimized machine learning models, and updates the predictions accordingly.
While advanced exoplanet classification pipelines exist at organizations like NASA, they are completely closed to public use. These systems are typically designed for a single mission only, not retrainable by external users, lacking any API or integration with external systems, inaccessible to students, independent researchers, and small research groups. As a result, high-quality astronomical data is publicly available, but the tools required to meaningfully analyze it are not creating a critical gap. Data democratization without tool democratization.
Celest AI directly addresses this imbalance by turning capabilities traditionally confined to large institutions into a public, deployable, and user-friendly platform. It solves three major problems: access inequality, manual time-intensive screening, mission fragmentation. Celest AI isn't just for professional astronomers. Researchers can save weeks per dataset, focusing on discovery instead of manual triage. Students and enthusiasts can explore real NASA data through an intuitive visual interface, turning astronomy into a hands-on learning. And for humanity, Celeste AI accelerates the discovery of exoplanets, including potentially habitable worlds, bringing us closer to answering one of our most profound questions: are we alone?